they just sent a couple of people, I don't know how many people, out to a junkyard or a couple of junkyards, just take samples of just random cars, and they wanted to see which one of them were the same, not just with the color. I'm sure they found a lot of, let's say, blue cars, but of all the cars they showed, which ones have the same, give the same IR spectroscopic spectrum. Which one give the same IR spectrum? And 1 out of 33,000 did that. Now, yeah, it's true that they would have gotten the same IR spectrum if they would have gotten their paint job, one after the other in the same paint place, the same, whatever it is, automobile facility, whatever they're called, wherever they paint cars. It's possible, but it was like 1 out of 33,000. So if you find they have the same paint, the crime scene paint, and the suspect's paint gives the same IR spectrum or same pyrolysis. In this case, they used IR spectroscopy to show that there was the same materials, the same components of the paint. If they show the same one, it's only 1 out of 33,000 that it was from different cars, but having the same IR spectrum, the same components. So it's if you can match the suspect's paint, the IR spectrum of the suspect's paint to the paint found at the crime scene, you have a very, very low probability that it wasn't him. It was somebody else who got the paint job at the same place. This is true for cars. For architectural paints, they found it even harder to find a match. It's even less than 1 out of 33,000. And they even tried using the same just white paint. Two different houses with the same kind of white paint. They pretty much found very different components, IR spectra of any two houses, even though they both had a single layer of white paint. So we add that to the fact that sometimes paint is found in layers, so we can find a chip with more than one layer, and they both have the same IR spectra, and they match to the suspects. That's pretty good evidence that the suspect was actually there at the crime scene. So we can work with that. The other thing that's done is we look at the paint. We look at the paint chip found. Let's say all we find is, let's say, in a car accident, and paint is found, on a victim of a car accident. We really can't just say that paint, say, oh yeah, that must have come from a Datsun 380ZX or whatever these cars are called, from 1997. You can't really just look at the paint and say, oh yeah, I know that came from this car. There are so many different kinds of car, different paint jobs, and also different models can have the same paint job. So you can't really just take a look at the paint and say, oh yeah, this came from this car made in that year. However, what they're doing is they have the paint data query database. It's a database that has all paint jobs from all automobile manufacturers, and I'm assuming also those who paint cars, not just from those who sell the cars or build the cars and then paint it as they build it. But so if we have that's again, it gives us more information. So we find certain kind of paint, we say, okay, how does this relate to the PDQ, the paint data query database? It indicates that, okay, this paint was used on these 4 or 5 different models. Okay, that puts us in a certain direction. We'll look for people who have all these possible models of car. Or if we know that it's painted by a certain automobile, whatever it is, paint facility, then we say, oh yeah, they use these kinds of paints. The paint data query says, oh yeah, they're using these kinds of paints. Okay, we're going to start analyzing these places. Who went to this automotive paint facility? It's not just the colors. It's also the paint layer, different layers, and the colors of the different paint layers. We saw there are several layers. We also have the paint binder composition, what the binders are made of. Remember, we're doing IR, infrared spectrum of these things. They give information on the binder as well, and so this database has information as to, we found it on our at our crime scene. Well, let's see who manufactures, who paints, using this kind of a binder. And in different states, different police precincts, they might have their own laboratory, and they have their own collected paint samples from, let's say, 5 different crimes. And so just to save, so they find a 6th crime where the paint matches. They say, aha, if we catch the guy in the 6th crime, we'll know who did the other crime whose paint is on record. So many laboratories, they have their own paint samples and their own information with their own paint samples that they want to use to compare to crimes in their own precinct or their own town or their own local area. To collect paint evidence, you have to know that if you find paint chips, don't touch them. Never touch them with a hand. They get wiped off. You might transfer your own, stuff, hand or whatever oils maybe to it. You want to avoid that. You don't want to contaminate it. Use tweezers and try to keep the chips intact. It's possible to match one chip at the crime scene to a suspect's vehicle. Not common, but again, keep them intact. Also, you don't want to lose, let's say, a layer. And if they chips into small pieces, they're a lot easier to lose. So use tweezers and try to keep them intact. If you find the paint on a garment, let's say at the crime scene, the victim was hit by a car, let some paint on the garment, keep the entire garment. Don't try to remove the paint from the garment. If you have a suspect, always try to get a standard sample from the suspect vehicle, and as close to the contact area, because from other areas it might be a different kind of paint. So try to get it from as close to the contact area as possible. You scrape it off. You scrape all the layers down to the metal because we want to know all the layers of the suspect vehicle. Because let's say only 3 layers were transferred to the victim. We want to be able to match the top 3 layers of the suspect vehicle to the 3 layers at the victim. So we want to get all the layers to match as many layers as possible. A 1/4 of an inch square, it's a small amount, that's enough. But make sure to get all the layers down to the metal, because the more layers you have, the more you can match to whatever was found at the crime scene, on the victim sometimes. Also, your knife. You don't want your knife to contaminate different samples, so use one knife for each sample, because if you use one knife for different samples, then the components of one sample on one knife will be transferred to the other one. So if you get your IR spectrum of the other sample, it might seem too much similar to the first one. You want to avoid this contamination. If you have paint chips, you can actually put them in what they call the druggist's fold. This was mentioned earlier, toward the beginning. Basically, you take a paper, you put these little chips on the center of the paper, fold it into thirds, and take the lengthwise and fold that into thirds and tuck one into the other. I'm not going to be demonstrating it, but it's a very quick and simple way of transporting solids in a way that they won't leak out of your container, if you only have paper, which is common enough. Paint, if it's found on tools, don't remove it. For one reason is that sometimes the paint itself might actually have identifying striations. So that's the main reason. So if it's on a tool, keep it on the tool. Another reason is to maybe find out how the tool was used. This tool was used for this paint, was in this part of the house, and that's why I picked up that paint. So don't remove the paint from the tool. Similar, at a tool mark, let's say the house had a bunch of scrapings on it from a screwdriver, don't remove the paint from any tool mark, because we want to keep the tool mark as pristine as possible so we can compare the tool impression to, let's say, a suspect's tool impression on a soft piece of lead, which is what's often done. So we compare the tool impression